this is Mr. Aiden. This is section 4.3, right angle trigonometry, and I know all you ladies are looking for Mr. Right, so at least we got right angle trigonometry. Anyway, remember our trigonometric functions that we went through last time? We talked about our sine, cosine, tangent, our cosecant, our secant, and our cotangent. And what do we know about our sine? Our sine is dealing with our vertical, or our y, divided by our hypotenuse. What do we know about our x? Our x is dealing with our range, our x, our horizontal divided by the hypotenuse. And our tangent is just like our slope, our change in y over our change in x. And what do we know about the cosecant, the secant, and the cotangent? Cosecant is the reciprocal, or hypotenuse over y. The secant is the hypotenuse over the x, the reciprocal of cosine, and cotangent is our x over y. And something else we know about, we know about our tangent is our tangent of theta equals our sine of our angle over our cosine of our angle, because sine is dealing with y over hypotenuse, cosine is dealing with x over hypotenuse, and you can see how we get this y over x. And so we're going to evaluate our 6 trig functions with this beautiful 3, 4, 5 triangle. Now, how do we get 3, 4, 5 triangle? Remember, 3 squared and 4 squared equals your hypotenuse squared, or 25, which is 5 squared. This is one of our special triangles, and you know, they're special. Anyway, here's our angle right here. Our angle is dealing with, sine is dealing with the opposite, so it's 4 over 5, which means what's the cosecant? It's 5 over 4, isn't it? Cosine is dealing with the x value, or the adjacent, and that's going to be 3 over 5, which means what's the secant? 5 over 3. What's the tangent is going to be opposite over adjacent, 4 over 3, which means what's the cotangent is 3 over 4. And it's as easy as that to evaluate our trig functions. Now let's say they give us this type of triangle, 3, 5. This is not one of those special triangles. So we have to take a look. 3 squared and 5 squared equals the hypotenuse squared. So we have 9 and 25. What's 9 and 25 equal to is 34, isn't it? Okay, so we have 3 squared and 5 squared, which is 34. The square root of 34 is going to be our hypotenuse, the square root of 34. Now, think about it. Can we do anything with 34? Can we reduce it down at all? So we just can't. And so we have root 34 right here. So let's take a look at our 6 trig functions. So we have our angle right here. Our sine is our opposite. That's 3 over root 34, which means what's the cosecant going to be is root 34 divided by 3. Okay. Now, take a look right here. We can't leave this value, can we? We can't leave a radical on the bottom. So we're going to multiply by root 34 on the top and bottom. So we have 3 root 34 divided by 34. Okay. Now, I like to write it out. And why do I like to write it out? Is it makes the reciprocal, the cosecant function, easy to write down. Okay, you'll see what I mean by cosine. Cosine is going to be adjacent, which is 5 over root 34. I have to rationalize this, so I have 5 root 34 over 34. But why did I write this first one down is I can easily do the reciprocal with this. I don't have to do any more work with it. Okay. And then what do we know about the tangent of my theta? Tangent is opposite. That's 3 over 5, which is adjacent, or sine over cosine, which means cotangent is going to be cosine over sine, or 5 over 3. And that is evaluating your trig functions. Okay. Now, we like to do a lot of word problems here, and so here I have the Wright brothers triangle, and you can see this surveyor is standing 50 feet from the base of a large tree. Okay, so we have surveyor 50 feet. Here's my little surveyor, not drawn the scale. Okay, and the angle of elevation, and this angle is 71.5 degrees. Now, keep in mind, we are in degrees, which means you need to change your calculator into degrees if you want to do this type of problem. Okay. Now, we want to know how tall the tree is. We want to know this y value, don't we? We don't really care about the hypotenuse here. So you can see we have an x value here, and we have a y value, which means we're going to use tangent, aren't we? Tangent of my angle equals y over x. So tangent of, what's my angle? 71.5 degrees. Make sure you're in degrees in your calculator. Equals y over your x of 50. So you can see I got to get y all by himself, so I need to multiply each side by 50, okay, to cancel that out. So y, or my height, is equal to 50 tangent 50 tangent of 71.5, and you just plug it in your calculator like that, and the y, or the height, is going to be 149.43. And take a look, we were in feet at the beginning, which means we need to be in feet at the end. Okay, and you have 2 feet on the bottom of your legs. Let's go to example 4. Example 4, we're going to use trig to solve this wrong triangle, and we are 200 yards from a river. So you can see this person's right here, 200 yards. We walk 400 yards, and so we want to figure out this angle. We want to find out this little cute angle right here. And so you can see, what are we dealing with is we're dealing with the opposite side, and we're dealing with the hypotenuse. So if we're dealing with opposite and hypotenuse, we're dealing with sine, aren't we? Sine equals opposite over hypotenuse. So sine of some angle equals, what's the opposite of this angle? Is 200. What is the hypotenuse? The hypotenuse is 400. And so 200 divided by 400 is 1/2. So sine of what angle equals 1/2? Now, let me show you how to do this in your calculator, and then remember, you also have this thing called a unit circle if it works out perfectly. Okay, so how do we figure out what this angle is? We have to do the algebra of sine, the opposite of sine. What's the opposite of sine? The opposite of sine is not cosecant. Remember, that's the reciprocal. The opposite of sine is what we call sine to the -1, or arc sine. It's on your calculator right next to sine. You probably have to push second sine or shift sine to get sine to the -1. Now, sine to the -1 of sine cancels each other out, and we're left with the angle. So angle equals sine to the -1 of 1/2. So if you literally put sine to the -1 of 1/2, and you're in degrees in your calculator, you'll get 30 degrees right there. Okay, if you're in radians, you're going to get pi over 6, okay, or some kind of weird number. So 30 degrees, and you can check that. 30 degrees is equal to 1/2. Remember your unit circle. If we're at 30 degrees, we're right here at 30 degrees. 30 degrees is your second finger, which means the sine is going to be the square root of 1/2, or 1/2 is going to be your sine at 30 degrees. And so that is the angle that we have right there. Unit 5, here we're going to take a look at finding the length of the skateboard ramp. What are we doing with this length? This length is the hypotenuse. We have the opposite side, so we're dealing with sine. Sine of our angle equals opposite over hypotenuse. Always set up your problem like this. It makes it a whole lot easier. So sine of 18 degrees equals opposite, that's 4, over hypotenuse, this is this C side right here. Okay, now remember, if you're ever trying to find the guy on the bottom, you're gonna you have to either do the reciprocal, you have to multiply out. I like to say you have to swap. So this C goes out here, C equals 4 divided by sine of 18 degrees. Again, make sure you're in degrees in your calculator. So 4 divided by sine of 18 ends up giving you 12.94. And think about it, feet. Okay, so this is 12.94 feet. Now, if you want to find the last side, you could do it by using the Pythagorean theorem. You could also have found this side over here, did the Pythagorean theorem to find the hypotenuse. Any way you do it, you can solve it. Okay, and that is 4.3, right angle trigonometry, a little bit of applications, a little bit of problems of how to apply our right angle trigonometry. See you guys.